One question that's commonly asked about basis is to find the basis for the null space of a matrix. And so you've already been asked before to find the spanning set for the null space of a matrix, and it turns out that because of the way the algorithm works, you automatically get something that's linearly independent. So finding a basis for the null space is exactly the same thing. In other words, all we need to do is solve ax equals 0. And the way we do that is we row reduce A. So if we row reduce A in this particular case, so let's just put it over here actually. So I row reduce this guy, and it turns out to just be 1, 0, 2, 0, 1, minus 1, 0, 0, 0, if you can believe that. And so what do we have? We've got x1 plus 2t is equal to 0 from the first row, and x2 minus t is equal to 0 from the second row. And we'll let x3 be our free parameter t. So x is going to be, let's see, so the first coordinate is going to be minus 2t, the second coordinate is going to be t, and the third coordinate is going to be t. So we have t times negative 2, 1, 1. And so any vector of the form some number times minus 2, 1, 1. So in other words, where the coordinates are in this ratio, where the second and third coordinate are the same, and the first coordinate is equal to minus 2 times either of those other ones. So anything like that is going to be a solution. And so what that means is that if I look at the collection of all scalar multiples of, say, minus 2, 1, 1, that's going to give me the null space of A. So before we said, hey, solve ax equals 0, and you would have stopped probably with this one. And so now we say, find a basis for the null space. And for that one, you just say, oh, okay, this vector right here. Now, we've also seen examples where there's 2 free variables at the end, maybe an s and a t. And as a consequence, there's also going to be 2 vectors. And so both of those vectors then would be elements of your basis, and you would have 2 elements in your basis, meaning that you have a 2-dimensional null space. And just a quick word on the geometry of what's going on here. The fact that this particular thing is a solution, that means that if we put it right here and we multiply, we're going to get 0, 0, 0, because that's the equation that we are looking for. So in particular, the fact that we have a 0 in this first coordinate, that means that this row is orthogonal to this vector because they have dot product equal to 0. The fact that I have a 0 here in the second coordinate reflects the fact that this row is orthogonal to this vector. So when I'm looking for the null space of A, the null space of A consists of all vectors which are orthogonal to rows of A.